All right, so what we're going to do now is we've been doing a lot of coding in this class, a lot of variables, a lot of functions, things like that. So the way that the curriculum is sort of structured is at the very beginning, you learn basic programming through nodes, things like that. And then in the intermediate, you learn data structures. And that's kind of what we're talking about here. And what we're going to do is we're going to use essentially a data structure called pathfinding. Now, if I pause the video for a moment, I'm going to bring up just a Google search of pathfinding to show you what I'm talking about. So it's important that you understand, even when you're interviewing for a job, that you're thinking about code as basic programming, data structures, and algorithms, and then lastly, design patterns, which we'll get into hopefully in game production 4. Now, the thing here is with pathfinding, essentially, if we look at the definition on Wikipedia, I think it gives a good one. It says pathfinding or pathing is searching by a computer application for the shortest route between 2 points. Now, if we think about this in the sense of our tower defense game, we have a bunch of enemy tanks here that are following a specific path. But what I'd like to do is I'd like it to be able to plant trees and rocks and stuff. And these tanks, again, who move extremely slowly, I'm going to go ahead and just kind of speed them up a little bit. But I'd like them to essentially just kind of go to our position or our point here. And let's make our speed maybe 1. I'd like them to, again, maybe not follow this specific path, but go to, just find the best route, whether it's blocked and stuff, on their own. So this is kind of leaning a little bit into the field of AI. So a couple of things I also want to do is I just want to select these. And again, notice I have my snapping on. I want to make my play area a little bit bigger here. And I'm going to hit Control D to duplicate that out. And just, oh, looks like it's not snapping. See, let's hit W here. It's on. I think we have to be global. Is that right? And then center, and then local, actually. Now we could turn this on. It should snap. Let me undo that a couple times. There we go. I seem a little bit close. What happened was I had it in local and not global, and that's the only way that this tool snap comes on. And then let's see. Let's grab these. See if this duplicates it for us. Control D. There we go. And then Control D again. I'm just again increasing the play area a little bit. And some of these values are going to go into the negative. And I'm doing this one at a time. See how these went into the negative because they're below our coordinate graph line. They're starting to go below, so now they're in the negative value. So our player is a little bit bigger. And what we can do is, again, same thing as before. We can just kind of mark these guys, tool, Pro Builder. And if you're using the Unity 6, you're going to have like a thing that says editors here, and then you'll just do import, open vertex coloring. And so, but with us, we have to open the Pro Builder window and then do vertex colors like this. And then we could just apply. Oh, actually, I think we just made materials. We weren't using Pro Builder for this. Sorry, I'm jumping between, here's the path, and then here's the ground. Maybe the path should be orange and the ground should be green. Let's do that. It looks like I got some other stuff selected. Anyway, we'll just stick with what we got. So, ground, path. Just think this went like dark orange or something. Anyway, all right, so we got that. So let's take a look at what pathfinding is, and let's get into how we can make decisions using pathfinding. All right, so back to our Wikipedia here to explain a little bit more. With inside of breadth first search, there's 3 algorithms. There's Dijkstra's, there's A star algorithm, and then there's the simplest, which is essentially, well, breadth first search is the simplest, and then we have Dijkstra's and we have A star algorithm. With breadth first search, let's type in breadth first search. What we can do is we start with this breadth first search algorithm, and again, this will make better sense when we start coding and stuff. Right now, it's all going to be like word salad. But let's check out this geeks. So breadth first search, what it does is it's traversing an algorithm used to satisfy a given property by searching the tree or graph. So we have this graph, right, of data structures. And so what you start off at A, and then it checks which is the fastest or the cleanest way to get there, right? So if B is the closer path and it's given B and C, it'll go to B, and then it just works its way down a set of given nodes in a graph. So let's take a look at, essentially, I guess we'll just go back in and we'll just start looking at coding this, and then we'll go over it again. All right, so inside of our tower defense game, I'm going to create a new folder, and I'm going to call it Pathfinding. And this is going to store everything that has to do with our pathfinding algorithm. So, sorry, my recording thing that you can't see was in the way. So we're going to call this Pathfinding. Now, the thing that, again, we have to mention is if we're starting off at 0, 0 here, with this, the way this is going to work is it's going to find the nodes that are the quickest between getting to 0 to 6, 2, for example. So we need to loop through or search all of the nodes that are nearby. So for example, if we're trying to get to 6, 2, it's going to look at 0, 0, 1, and then minus 0, 1, and 1, 0. So it's going to find all three of those nodes that surround it. It's going to say, you know what, 1, 1, or actually all of these that search around it. So, and then it's going to map 1, 1. It's going to store that. Then maybe 2, 2. Then all of these to go straight across. And what it does is it stores all of those inside of a graph tree. And this is what we're going to code next. It stores all those in the graph tree, and then it goes back and it reviews it. And it's like, okay, that is the fastest route is for me to go across or whatever. All right, so go ahead and right click on Pathfinding here and go to create a new C# script, and we're going to call this the node class. And let's go ahead and just drag that in here. And I'm going to close these other ones for a minute. And this is going to be the script that handles all of these nodes. And actually, let's go ahead and let's open up these scripts. Let's open bank, and let's just copy this namespace TD here. And I'm just going to paste that on the top, and then just duplicate this by hitting Control D, and then Control Alt Enter. And honestly, Control Alt and Enter doesn't seem to be working for my laptop all of a sudden, so I have to go back and check it. So if it's not working for you either, it seems to be doing the same thing to me. I don't know if it's the latest update. So let's go ahead and remove start and update here. We're not going to need those. I'm going to zoom in a little more, hit Control S. All right, go ahead and delete the colon and mono behavior because we're not going to be using mono behavior. Mono behavior is where update and start and all of those other things are located. And this class is going to sort of exist on its own to represent these nodes. So for your own vocabulary or terminology, anytime you do that, this is called a pure C# class. So whenever you hear the term, is it a pure C# class? It's this right here. The other thing behind this is if we save this, we can't add this to a game object because it doesn't derive from mono behavior. So this has a specific purpose. I use it a lot for tracking information and data, is to use pure C# classes. So let me kind of show you that really quick. So if I go inside this pathfinding folder and I drag this node on here, you see it can't add script behavior node. The script needs to be derived from mono behavior. So that's what this is. So that's the mono behavior library is what allows us to access all of those cool things to affect game objects. All right, so I went ahead and created a bunch of variables. And so let me sort of explain what each one does. We have a public vector2 of type int, because remember these are integer values here, and it's just going to be coordinates, and it's going to store all these coordinates. And then what we're going to do is we're going to check if which one is walkable, which one is explored, and which is part of the path. And that's what these Boolean values are for. And then we have this last one, which has the same name as our class, and it's called node. And what this variable is going to store is which nodes around here are these 0, -1. These are all, I consider them nodes. So between 2 points or waypoints, we call them also nodes. So this variable here is going to be used to store all of these different points or these different nodes that are surrounding it or whatever it's connected to. So say we're at 0, 0, it's going to check what it's connected to. All right, so I just added another function or method here, and you might notice something that it's called the exact same thing as our class name, and this is called a constructor. Do you remember with our start method when we created a model behavior? It's called the second that the script is attached to a game object. So when you press play, it automatically goes into start or update. You could think of a constructor as the same thing. The second that we press play and we run our game, anything that this node script references, it automatically runs the code that's inside of here. So what we're going to do is we're going to call this method when we have the coordinates. So we have a vector2 int here. This is a new one. And it's called coordinates. And then I'm going to add a bool here called is walkable. And we're going to pass those two things into this node. And that's just going to check, well, what is the current coordinate of it? And then is this object itself walkable? And this will give our enemy the ability to, or our enemies as they're going through, we're going to pass in the value of whatever's around it and is walkable. This will make better sense when we're moving along, but just understand that, remember, we're passing in values here. We haven't done anything that's to and stream. A constructor is just like the start method. It's called the second the script is called. Now, you might be wondering too, you might say, well, isn't it trouble that we have these named the same thing? The reality is I normally would name these something different, but I want to show you using this keyword. So I'm going to type this, I'm going to hit period and hit coordinates. Notice by using the word this here and highlighting over this, it automatically knew that I was referring to this coordinates. So I say equals and then coordinates here. Notice that it knew that this was referred to the coordinates being passed in because the word this keyword refers to the variable name here. So if I hit Control D here and I just grab is walkable and I replace it here and here, you can see as I save that, if I click on this is walkable is referring to this one that's highlighted. And if I click this, it's referring to this Boolean value here. Now, I don't want this to give you anxiety. Again, this is all basic stuff. So how do we manage all of this and check if it's like where all these are and they're stored and stuff? It's pretty easy. Inside of our pathfinding node, I'm going to right click in here and I'm going to create another script. Remember, single responsibility. We're going with that philosophy. And we're just going to call this grid manager. And this script is going to be used to manage all of our nodes. And again, when you're coding your own games, I always suggest you code your own game outside of class and just try to make your methods as simple as possible and your scripts as simple as possible, and then build it out for your own game. And build a simple game. Because notice, like, even this game, which is just a tower defense game, requires so much, right? So let's grab grid manager and drop it in here. This is essentially our grid manager script. So let's use this grid manager really quickly to test our node. So here's our serialized field, and I'm going to make a variable here called of type node, right? So I'll save that. And let's see. We're in our grid manager script. Let's make sure we also have this namespace up here. Duplicate this, Control Alt Enter. There we go. That should let us, because you're not using the same namespace, it freaks out. And then just inside of start, I can just say debug.log. And then inside of here, node dot, and you remember we have coordinates, and I'm going to hit Control D on this, and then walkable. It's walkable. So I'm going to save that. So in order for this node class to be seen, because remember we have all of these public variables here. So for example, let's go ahead and I'll just show you an example. I'm going to create an empty game object here. And on this empty game object, this is going to be for testing. I'm going to drag my grid manager. Notice that it's not showing me, like, because we have is walkable and coordinates that we're trying to use here, and we don't see this serialized field of node. And the reason for that is because we need to make sure that we specify that this whole class, let's do system, is serializable. So if I hit Control S and I save this and we jump back in our scene, you can see we now have a node. We can have access to the pure C# class, those coordinates, whether it's walkable, explored, if it's a path, all that stuff. And it's on this game object here. All right, I'm going to hit Control Shift C here. And notice that we have, all we're doing in start here inside this grid manager is we're just printing to the screen the coordinates in this walkable. So let's say the coordinates of this object is 2, 2, and we have checked on is walkable. Now if I press play here, you should see 2, 2 and is walkable is true. That's checked on is true. All right, I think that's good for now. This video is getting pretty long. What we're going to talk about in the next video is a new data structure called dictionaries and how we can use that data structure. Now, remember, dictionaries are arrays, data structures are arrays, lists. Even a variable is considered a data structure. It's a way of saving data inside of a structure. So we're going to move into that in the next lesson.